Hello, proximity math here. I'm going to go over the 2014 SMT Advanced number 9. So it sounds really simple. Compute the smallest positive integer n such that the leftmost digit of 2 to the n in base 10, of course, is 9. So we have 2 to the n equals something starting with 9. Smallest n. So all we want is find the n. Okay, so if you list the first few powers of 2, you have 2, 4, 6, 8, 16, 32, and then he'll have even 8,132, something like 1,048,576 into the 20, but no 9 in sight. So it's not really trivial. But now notice the leftmost digit is 9. Well, notice that every 10 powers of 2, well, you should know the fact that 2 to the 10 is 1024, which is approximately 1000, a power of 10. So that means every 10 powers of 2, it approximately repeats, at least the first few digits repeat, because you're multiplying by something that's almost a power of 10. That's the very first thing you should already see. And then, so you have 64, 128, 256, 512, and then 1024, which is analogous to this 1 we have as 2 to the 0. So usually our leftmost digits are going to be something like these. And clearly the closest one to a 9 is 8. Since 1024 is slightly more than a power of 10, that means if we multiply that enough and jump powers of 10 in jump 10 powers of 2 enough, we're gonna go from that 8 to a 9, like by enough exponents of 1024. So we don't care about how many zeros or how many digits there are after that. All we care is about if you have something that's approximately 8 times some power of 10, which is a power of 2, then if we multiply it by this decimal, our goal is to bring this to a 9, because we don't care about, I'm keeping it a decimal because then it won't just jump to 80 or 8,000. It's going to keep 8 and then it's going to get slightly bigger and then eventually get to 9. So for some k, we have this is going to be greater than 9. And this is only approximately 8. Like, we have 8 or 8,132. So it's only going to give us an approximate answer, but very accurate. And now, if you understand that reasoning, then we can move on, and you have 9/8. We can move it to this side, and now this is 1.125. After I used that reasoning, I also found like 1 plus some really small decimal k raised to some power n is going to be approximately 1 plus nk, or in other words, 125. Okay, make sure you don't get that decimal wrong. 24k is greater than 125, so obviously we're going to have k in actuality is going to be around approximately 5 well, we have 120 and then 5 over 24, which is approximately 5.2. Okay, so k is approximately 5.2, and note that when we're raising 1.024 to the k, what we're really doing is 2 to the 10 to the k, since we don't care about how many zeros or digits there are after. So since we have k is approximately 5.2, that means our answer is going to be around 2 to the 52. So n is around 52. And we have that 2 to the 50 or 2 to the 10 to any power is going to be basically a power of 10, 1024 to some power, which is going to end with, start with a 1. So we need 3 more powers in the units of n to make that an 8, or in this case a 9. So since it's around 52, we must have that n equals 53 to possibly have a 9 as the first digit. There's no other unit digit number, and using this approximation you can find those. Thanks for watching, and I hope you enjoyed.